Welcome to the Innovators Playbook podcast. I am your host, Seth Narayanan, founder and CEO of Telient Systems. Each week, I'll be sitting down with entrepreneurs, product leaders, and technologists who are solving real-world problems with bold ideas and smart execution. We will dig into what is working, what's not, and the lessons they have learned turning vision into reality. If you're leading digital transformation, scaling a startup, or just curious how innovation really happens behind the scenes, this is your playbook. Let's get started. Welcome to the Innovators Playbook podcast. I'm your host, Seth Narayanan, founder and CEO of Telient Systems. Today, I'm honored to have Francis Govers join us. Francis is a seasoned technologist and author who currently serves as Director of Engineering in Uncrewed Systems at Airbus, U.S. Space and Defense, where he focuses on cutting-edge developments in AI, robotics, and aerospace innovation. Over the course of his multi-decade career, Francis has worked on some of the most ambitious projects in autonomous technology, from industrial robots and NASA space systems to self-driving vehicles, AI-enabled security platforms, and now autonomous cargo aircraft. Beyond his deep technical expertise, Francis is also a prolific author and public speaker with 10 books, 48 papers, and over 300 talks to his name. He is especially passionate about the intersection of artificial intelligence and robotics and the future of intelligent machines that can not only move and fly, but think and collaborate. Francis, welcome to the podcast. It's a pleasure to have you here today.
Thank you, Seth, and thanks for inviting me. I'm very excited to be part of the conversation.
Wonderful, thanks. So why don't we get started? Your career spans from industrial robotics to NASA to self-driving cars and now autonomous aircraft. So what inspired your journey into these diverse fields?
It was something that just happened to me along the way. I started off as a communications person. I was a satellite communications person in the U.S. Air Force and then moved to NASA, where I specialized in telemetry and communications. And along the way, what do you do with communications? You use that information to control things and control things at a distance. Quite specifically, working with the International Space Station and some of the other projects that we had at NASA where we had robots involved, we had autonomy and computer vision and other sorts of techniques. And along the way, it spiraled into the world of unmanned vehicles and autonomous vehicles.
Wow, that's pretty impressive that you have such kind of broad experience. And when you are involved in robotics, we are talking both hardware and software, right? Is there a passion for one over the other, or are you equally intrigued by both hardware and software?
Honestly, equally intrigued. I've been the mechanical designer and software designer on various projects, sometimes both, and now as a chief engineer and director of engineering, I'm responsible for both ends of the design. And so for both mechanical side and the software side. And I really enjoy all of them. I enjoy gears and gear trains and actuators in particular, controlling them and creating motion algorithms and such. And so to me, honestly, I really enjoy it when you build something and then it moves.
Yeah.
That to me is amazing. So I never get tired of seeing the stuff that I've built either moving or even just sitting on a shelf as something I've created.
Yeah, that's really cool to see that. And you've worked in AI, which is the latest and greatest in software now. As we all know, AI has been around and maybe not quite called that, but it's been around, but it's gotten a new life in the last 3-4 years. What is your perspective and how do you perceive the evolution of AI with all these generative models that has come out now? And how is that impacting your industry, either directly or indirectly?
Yeah, it's having a very big impact. I've been involved in AI since the late 80s, early 90s, so quite some time. And admittedly, a lot of the techniques, even today, a lot of the techniques that we use, neural networks, expert systems, were originally conceived in the 60s. And even some of the concepts like Siri and some of those tech voice activated systems are quite old. But now two major advances have really changed the way we see this. First of all, the dramatic increase in compute power means that we can do an awful lot more computational, and the ability to collect and amass any amount of data, enormous data sets, billions of images, billions of pieces of writing. So that makes training available that was never available before. Before you needed to assemble a training set, you had to do it yourself. You could go out and take pictures or go build a model or whatever.
Right.
And these days, it's just a matter of a few clicks. The infrastructure available to us has just been amazing. I will say the more recent trend in generative AI, there wasn't really a big change in how AI worked up to that point. We were doing pretty well with neural networks and object recognition and stuff. But the addition of generative AI, where we have latent space and we have the ability to abstract models and represent ideas in vector space and apply learning to that, has really dramatically expanded the world that we can apply AI to. Now, on the other hand, I have to say, we're still not to the point in the autonomy world where we can do much more with that other than recognize objects and potentially classify things. But in the world of user interface, so talk to a robot in natural language, say, hey, go over there and pick up that toy. And before, I've had to set it very precisely. And these days, we can create a framework where general language understanding can happen. And that's an improvement. So there is that.
Yeah, you mentioned latent space. Can you expand on that a little bit, and what is its significance in robotics?
Sure. So latent space is how the neural network encodes information. And it's really quite dramatic, the amount of information. For example, an art program like DALL-E has millions to billions of images, and those, rather than being stored as pixels and dots, have been represented as somatic representations, a multi-dimensional vector, usually in 4096 dimensional space. And we can represent relationships and volumes in spatial relationships in this higher dimensional space. And that's latent space. And it can also be used to encode not just images and words, but also motions and trajectories and plans in those sort of spaces as well. My term I use is it's given us the ability to simulate an imagination, which is an interesting concept.
So are you using either generative AI or any of these new tools to make the robots more adaptive and more intelligent in some ways that maybe was not possible earlier?
Now, admittedly, the work that I do as my profession, I work with autonomous aircraft. And for those, we have very strict rules about deterministic behaviors and safety and so on. And using any kind of a generative AI in that context is very problematic. Generally not that. But certainly in the world of planning, like I said, path planning, path creation, and cooperation, there is some room for generative AI to be a tool that could be used in not just working with single robots or single vehicles, but with groups.
Like maybe involving fleets of drones.
Fleets of drones, fleets of cars. You could think of if you were a warehousing company and you wanted to organize the warehouse for rapid retrieval or make things more efficient. This is a technique that could be employed to innovate new ideas.
Yeah, so coordinating an army or some kind of a unit that is working together, there is a lot of challenges within that. I'm sure there are a lot of complexities involved when you want to have a group of autonomous robots or vehicles kind of work together and coordinate action. You see that apart from the safety aspect of it, hope it doesn't come to that. But if it ever happens, do you see that is possible in terms of where technology?
So, yeah, and there's a number of models that you could look at to create this sort of interaction. And actually, in my bookcase at home, there's a whole series of books on ants and bees, specifically for this exact problem that we're concerned about. How do we work with a whole group? Say we're doing search and rescue, and we want to send out 100 vehicles to go do a search and rescue. You would divide that into some amount of specialties, and some parts of the group would be searching, and some parts would be supporting, and some parts would be preparing the search, and others would be reporting. And then you say, okay, now we've located something. Now we want to out to rescue. You know, how would that get organized? In Hive, you can think of dividing labor by specialty and then organizing. Each individual has their own kind of little piece of the plan, and together as a group, they can then solve the problem. So actually, a fairly small number of primitive actions for the individuals still add up to very complex capabilities For example, one of the things that ants use is to lay down a pheromone trail, which is a trail of scent along the ground as they travel about. And the thing about it is that the more ants go on a particular path, the stronger that pheromone becomes, the more likely it is that another ant's going to follow that path. And that as a concept for something like search and rescue, or even optimizing delivery trucks for Federal Express or UPS, could use the concept to say, here's the routes I use the most often. Let's reinforce those and use that to create some sort of an optimal solution to what could be a very difficult problem.
Yeah, that's very exciting. What is possible? You've created personalized AI assistants for research. How do you envision the future of personal AI? Personally, for me, for example, even in a home situation, would be great to have a robotic assistant that can do some of the basic chores that, somebody needs. As simple as move clothes from the washer to dryer, right?
Now, that's what's featured in my latest book, Artificial Intelligence for Robotics. The tech presented itself because I have 5 grandchildren.
Yeah.
And when they come over to our house, we have a big toy box, and they would take every single toy out of the toy box and then amazingly uniformly distribute them all about our house. It was amazing that you couldn't come up with a system that would be more uniform in the toys per square inch. It was just amazing. They managed to get every square inch of the house covered in toys in a remarkably short amount of time.
My
And
wife is very particular that anybody that comes and plays cleans up and gets everything back in the basket, but not always, it doesn't always happen.
yeah, and we have a different philosophy in our access. The idea is we want the grandkids to want to come over. And so trying to encourage them to come over and play,
Yeah.
and they do quite often. So it just presented itself. And from a robot problem, it was complex enough to be interesting. In the robot world, we try to have structured environments where everything is exactly in the right place. You can think of a factory where we're going to pick up a bolt and stick it in a hole, and the bolt's exactly in the right spot. And you can do that literally blindly, where the robot can just, by coordinate system, pick up an object and stick it somewhere. And in the case of the toys, they're randomly distributed in random orientation. So when you start to look at that from a robot perspective, it's challenging enough to be interesting. And that's where the AI part of the book came along and then say, okay, now we got to apply a more sophisticated capability to recognizing toys and then grabbing the toys and then manipulating them and putting them away and navigating in this space. And it's like not falling down the stairs because there's a staircase there. So actually, the robot solved the stair problem by itself. When I created the navigation system for this particular robot, I drove it around with a little remote control, like a radio control car, and drove it all around the house. And since I never drove it down the stairs, it never had that encoded in its behavior to go down the stairs. So that kind of taught itself not to go down the stairs, in that I had never driven it down the stairs accidentally. So it was never in the training set. So it doesn't go down the stairs. It just stays on the floor.
Yeah. So with AI and machine learning and all the latest that's available in this technology, is it possible to decouple the mechanical aspects of the robot and the algorithmic aspects of the robot into, I don't know, for a lack of a better word, server or cloud, where you can keep training the same robot into new tasks?
Right now, it's more specific, but I think in the future, we can take this concept of generative AI and latent space that we just talked about and use that to put motions and think about putting not just the actual mechanics of grasping, but the concept of grasping as a latent space representation. Say, here's all the different ways you can grasp something. And then let the robot then choose based on the situation, the grasp that it needs for that. And that would be a learned behavior. That's where we're headed with this stuff. And I think that's at this point quite doable. In fact, that will probably be the subject of a future book. The publisher and I are already plotting what the next book in the series would be, and that's going to be part of it.
Yeah, that's really amazing. You are in such a intersection of both technology. Has there been anything surprising that has happened in this AI and robotics journey recently that has really made you jump up and sit in your chair?
In some cases, it's been the more things change, the more they stay the same. We're having the same kind of problems with AI that we were having 10 years ago. We've got much better training, we've got much better data sets. I do like the generative AI approach to things, has opened some new doors in created some new tools. It's still a ways from being something that's useful for actual work. I have to say, up to this point, I've had a number of times when I've tried to use some of these tools to do a particular task to the quality that I expect for work, either as a writer, as an artist, because I'm a professional artist as well. And it's just not there. And it's been a disappointment. And it's good enough to get ideas and it's good enough to do organization. For example, if I'm going to write a technical paper, it's good enough to organize all the ideas, but not good enough to publish. It just doesn't come out yet the way I would consider to be professional quality as someone who's been a professional writer for 40 years. It's just a question of quality and style at this point.
I was just reading an article about the generative AI for software code generation. And what I read was some senior engineers actually feel that their productivity dropped when using AI. So there have been anecdotal stories about it where senior engineers feel like they're good in creating pieces of logic or methods or procedures, but then somebody has to glue it together. It is not a whole solution. Surely for junior engineers who are normally given these tasks to write individual procedures and methods, they can use AI and their productivity increases. But for senior engineers, it's actually not as helpful, is what I read.
Yeah. I use it a lot for when I teach classes and things. I've been using it to make examples, and I appreciate it for that. If I'm going to teach a class about how proportional integral derivative controllers work, I can create a little program for it with a little cartoon in 10 minutes, and I appreciate that. As far as doing something as complex as the stuff we do for work, you would spend more time fixing it than you would getting productivity out of it.
Yeah, that's something that I think we are starting to run into. And I'm also reading a lot of articles about AGI versus LLMs, right?
One of the hallmarks we would call of AGI is that a program is capable of doing something that it was not programmed to do. Some of that is starting to happen in ChatGPT. You could tell it to, for example, I talked it into playing blackjack, and it's not programmed to do that.
Yeah.
And interestingly, it didn't do it perfectly. It made mistakes. But yeah, I just don't see in this the path that we're on right now that AGI comes out of that. I think you'd have to go in a completely different way of creating an artificial intelligence. And I had one of my previous bosses when I worked at Silicon Graphics, which you may be aware.
Oh, yeah.
We were doing supercomputers, and I've been involved in supercomputer research, real-time operating systems. I helped design some of the very large computers for the U.S. Department of Energy.
My son actually works for Los Alamos.
Very good. Yeah. I helped build one of the computers at Los Alamos.
Oh, really? Okay.
Blue Mountain.
He loves getting time on that machine. Yeah.
And I did the graphics for that. I designed the graphics engine for that computer. But the bit is that a group split off from there and they went off and created something called the Blue Brain Project. So this group in Switzerland, the Blue Brain Project, is trying to actually build a artificial neuron that did work like a real neuron does.
Wow.
Because real neurons have training effect. Again, this concept of path reinforcement practice. If you're going to learn to play a musical instrument, you repeat over and over again, and those neural pathways become smooth. The neurons have processing inside of themselves. They don't just transfer the impulses, they actually process the information as well. So it ended up that an actual neuron needs about 10,000 lines of code as compared to the 4 lines of code that are a typical neural network in an artificial neural network. It's probably 4 lines of code. It's got a weighting function, it's got the activation function and the transfer function, and 4 lines of code. Their artificial neuron had 10,000 lines of code. So until we start doing things that way, I don't think we're on the path to an artificial general intelligence.
Very interesting. You have written a lot of books and you're very insightful. And your latest book is Artificial Intelligence for Robotics. I think I saw there are 2 books in that. Is that a series?
Second edition, yeah. We did the first edition in 2017.
Okay.
And then, so the new edition came out this last year, 2024.
Great.
So
can you share a little bit about what's in that book and what we would get out of that and who the audience is?
There's 2 parts of it because I wanted to introduce people to my world of designing robots. Now I'm on my 33rd something autonomous vehicle, and most of mine have been quite big. The largest one was 18,000 pounds. So that's quite a vehicle. And I do full scale helicopter. These days, I'm working on full size helicopters, 8,000-pound flying machines. So I work at the very high end of robotics on very large devices. I help design the International Space Station. First of all, I wanted to introduce some concepts of approaching autonomy that I have found very useful that I've learned over the years. I generally explain to people one big advantage of my experience in autonomy and robotics is after 30-something vehicles that I've learned an awful lot of things that don't work. The first thing we kind of learned is the complexity is you're in that you've got to figure out a way to compartmentalize and to separate out functions and to simplify the interactions. So the first part of the book is some of my guidelines of how to think about making decisions. So you have to understand, how do you make decisions? I have a particular model for decision making that's actually well established in the world, which is called the OODA Loop. It's created by a guy named John Boyd to describe how the military makes decisions, but it applies to robots just as well. So the OODA Loop is observe, orient, decide, and act. So observe the outside world, use sensors to figure out what's out there, orient, to determine what information out of that is relevant to the robot. For example, let's take our pick up the toy robot. So we're going to have a robot sitting in a room and their toys scattered about. So the first thing we do is observe. We use the camera and we look for toys. And we have an algorithm that looks at the image and recognizes it and draws a box around each toy that it sees in the image. We have to then take that information and go in the orient step. Is it close to us? Is it far away? Is it to the right? Is it to the left? How do we navigate to get to that toy? So we now got to move from where we're at to where the toy is. So that's the orient step. And then where is it relative to the robot? If we had multiple cameras, let's say we had one in the front, one in the back, we would actually have to adjust the reference frame that we would know, oh, that's the rear camera. So that pixel is behind us, whereas this pixel on the front camera is in front of us. So then we've done the orientation. So the next thing is to decide, the D part. So decide is, well, what am I going to do about it? Okay, the toy's over there. I've got to move from where I'm at to where I want to be. I've got to come up with a path. Are there any obstacles in my path? So we do an analysis of alternatives to create a choice of actions. So once you've figured out your alternatives and go, how am I going to get there? So now we've come up with a path. Now we have to enact that path. And so send the commands to the motor, to the wheels, or to the arm to physically move the robot. That's the act part. So those 4 steps make up the decision-making cycle of the robot. If we're doing something more sophisticated like a car, we actually have to divide those decision-making into layers. And when you're driving your car, 3 levels of things are going on. First of all, the motor's running by itself, the air conditioner's on, the wheels are turning. That's all done autonomously in the car. That's the systems of the car. You don't have to think much about those but the car does.
Right.
The gas is being pumped into the carburetor and then going into the pistons. That's the bottom level of what's going on. And then in the middle level, you're driving the car and you're looking out ahead of you and you're on the street and you're trying to stay on that lane of your street. And you're also avoiding other cars and avoiding pedestrians, avoiding dogs and things. So this kind of local awareness or local navigation, keeping you on the path. And then finally, the upper part of your brain is going, if I'm going to the grocery store, I have to go down Main Street and I got to turn right on North Street and then I've got to pull into the parking lot. That navigation part is your mission that you're on. You're on a mission to get to the grocery store. That's the upper levels. In the design of autonomous vehicles, we have the systems level, we have the operations level in the middle, and then we have a mission level on the top. Dividing and isolating those interfaces lets us simplify those tasks and also to realize that we're doing multiple things at once. You can't do a self-driving car with a single threaded operating system.
Yeah.
You need to have multiple things going on simultaneously because you're doing multiple things simultaneously. That revelation also made it into the book and was an important part.
Is it for hobbyists and people that are trying to get into robotics and into AI, or is it more for advanced?
Sneak in the advanced stuff. It's designed that anybody can go buy a robot off of Amazon and do the stuff that's in the book. It is regular components. There's nothing fancy there, but the concepts honestly are on the path, I would say, to professionalism. It's done in a professional manner and the concepts are presented in a professional manner. Even though we use an amateur robot to do it with, we're still doing it in a professional way.
Very cool. The really cool part about your book is it's written by a practitioner, somebody that's in the field doing it, versus not that I have anything against professors that are teaching, right, in a lab, whereas you're working in actual large industries that are implementing a lot of these technologies, and you have the inside view of all that, and that's phenomenal. And that would be a great benefit to the readers. So I encourage everybody out there to go get this book and put it on your Christmas list or something for anybody that is interested in robotics, including me. So where do you see the next 5 years, specifically in the project that you're working on without giving anything classified out, and also generally in the industry?
We're working right now on cargo delivery. We're just doing it on a bigger scale. We're working on cargo delivery vehicles of a bigger size that are helicopters and that are able to deliver cargoes autonomously in various situations. So that's pretty
That is really
straightforward.
cool. What benefits that'll bring?
The benefits for that are bringing materials places where it might be difficult to get to. You think of an oil rig in the middle of the ocean, or somebody in Alaska at a gold mine in the middle of nowhere that wouldn't have access to those roads. We could be delivering supplies in those kind of areas.
Yeah, really cool. That's
Yeah.
phenomenal. Yeah, you've been a pioneer and innovator in robotics and aerospace and in technology. So, what is your advice to people that are trying to get into this field? Not
Yeah.
that it's easy to do or whatever, but there are a lot of people that want to get into it.
One of the joys of my job is I get to mentor. I work with a couple of local universities here. I'm located in Dallas, Texas, and I have a partnership with the University of North Texas and the University of Texas at Arlington. I get to mentor students on a regular basis. I've also been involved with the Vertical Robotics Challenge, which is a competition for high school students where they get to build drones and robots and test them in a competition sort of area. So I've been involved with helping students for quite a while, and I routinely mentor students in these areas. And I say to have the interest is the first part. The main thing about me is not that I'm particularly talented or anything, but that I'm just quite interested in this particular field and what I'm doing. So cultivated interest in it. You can do your own research. There's so much material available out there, and actually go get some motors and get some effector cameras and try stuff out and build things. It's quite easy to get started, but I do recommend that you spend some time looking at what's been done in the past and look at things like the DARPA Grand Challenge and some of the other events that have happened in the past that shaped a lot of where we're at today. And you will learn, you will need math, you will need science, but also imagination. And there's a place in this field for all skill levels. Here at Airbus, we have all sorts of talents. We have people who are writers and artists and designers and electrical people and mechanical people and hydraulics and control systems and so on and so forth. It's amazing the number of different ways of expressing. As I said, I've had to do both mechanical and software. I've had to learn welding, I've had to learn machining. 3D printing these days has been very useful. We do a bunch of laser cutting, and all of that becomes part of what we're creating.
Yeah. Wow. Yeah, definitely there's a lot there and a lot of different ways somebody can get into it. But the step is to learn, and maybe they can learn some from your books to get started. Francis, thanks a lot for your time today. I think this has been really enlightening and great to hear your thoughts on all these topics around AI and robotics. And thank you for joining the Innovators Playbook podcast.
Thank you so much for inviting me, Seth. I really appreciate it. The time went by very fast, didn't it?
Yeah, I did. Thank you.